two-loop circuit. Let's say 20-volt battery. $10-volt battery. Let's say we have two resistors here. Let's say 20 ohms. Something like this. This is a two-loop case. So it has one loop here and then another loop here. Yesterday's one that we did was where we had to do 3 loops, I believe. It was something that looked like this. It was like this. Then it was something that went down like this. Then there was a battery here. Then there was another resistor here. So that's kind of like 3 loops. You have 1, you have 2, then you have 3. And then when you're analyzing them, your loops don't necessarily have to be those 3 that you do. So here's 1, here's 2, here's 3. Well, what I did is I did this one, I did this one, and I did this one. So I did it where I always started it here. So it doesn't really matter that you have to always do this one and this one and this one. You could do this one, and then this one. Okay, so here there's 2 potential loops. There's 1 and then there's 2. Or I could also do the whole thing. So then what you do first is you set up the currents. You say, I'm going to call this current here I1. Then this one here going down, I'm going to call I2. And then this one I'm going to call I1 minus I2. So I1, straight up I2, and then here's the remaining what's left of the I1. So I1 minus I2. Then I'm going to do the left loop. So then I'm going to go this way. I'm going to gain 20. Then I'm going to lose 30 I1. Right? So when you go with the current across a resistor, you lose voltage, right? Then you go here this way with the current, you lose voltage also. So you lose 10 I2. And then here you go from the positive to the negative of a battery, you lose another 10 volts, you see? Then you come across, there's nothing lost. So then that's equal to 0. Then you simplify this. 20 minus 10 is 10. Then this one goes over to the other side. 10 is equal to 30 I1 plus 10 I2. And then we could cancel the 0. So that's our first equation. 1 is equal to 3 I1 plus I2. Okay. Then I'm going to do the second equation. I'll do the whole thing again. Or you could do this one, right, for the second loop. So if I do this one, I'm going to do 20 minus 30 I1. You go this way. Then you go this way, minus 40 I1 minus I2, and then minus 20 I1 minus I2, right? This is 20 here. That's equal to 0. And I could get rid of the zeros. and take everything to the other side. So 2 is equal to 3I1 plus 4I1 minus I2 plus 2I1 minus I2. So since these are in series, I could simply just say, okay, just add these two, right? And you get here it's going to be 6I1 minus I2. Right, and then you're going to add these two. So it's going to be 2 is equal to 3 plus 6. That's going to be 9I1. Okay, 3 plus 6, 9I1. And then the 6 distributes here, negative 6I2. Okay, so this is my second equation. So there we go with the simultaneous equation solver again. We could use the one that we found online too, just in case you don't have the simultaneous equation solver. In this case, you can just use the online one. What was it? Simultaneous equation solver. And then we can just put, what was it? 3x plus y is equal to 1. And then 9x minus 6y is equal to 2. Okay. I guess it did it. Okay, so I1, what there we called X is I1. So I1 came out 8/27, and I2 came out 1/9. So I1 is 8/27, so what is that? .2963 amps, and then this is 1/9 should be 0.11, right? 0.1111 amps. So once you know the currents, then of course you know everything. We can find out the voltage across this, the voltage across this, right? So then if I1 is going to be 0.2963, then if I want to know the voltage drop across the 30 ohm resistor, I do what? I1 times 30. So 8/27 times 30. So then I just multiply the current, right, by the resistance. So 8 divided by 27 times 30, 8.888 with the repeating 8s. So that means the circuit looks like this. The voltage is 8.88, repeating 8s. So this is, I'm writing the voltages down now. The current is going this way. Then I2 is this way. So then for that one, I just multiply 10 by whatever I got with I2. So that's 1.11. 1.11 repeating once. Then this is 10. Then this is 40. And this is 20. So then what would be the current on this side? Then it would be I1 minus I2, right? I1 minus I2. So let's do 8 divided by 27 minus 1 divided by 9. Okay, so the current on this side is going to be 0.185, and so on. It's probably repeating. Okay, then I'm going to multiply that by, yeah, exactly, 0.185, 185, 185. Then I'm going to multiply that by 40 to determine the voltage drop there, 7.407. So here the voltage drop is 7.4074 volts. So the current is going this way. And the current here is going this way. So then here the current is going to be, here the drop is going to be half of this, right? 3.7037 volts. Okay, so now after you get the answer and you draw the voltages, one way to check also is to do this. Go around any of the loops and the voltages that you gain and lose should add up to 0. So if I start here, I go this way, I gain 20 volts. I go this way, I lose 8.8 with repeating 8s. Then I go down, I lose 1.11 with repeating 1s. Then here I lose another 10. Then I come back down and then I close the circle. So all the voltage gains and losses should be 0 if you do a complete loop. 20 minus 8.88888888 minus 1.11111111 minus 10. You see that? 0. Now, how about if you start here and you go like that? You see, anywhere, you start anywhere and you go in any direction. You start anywhere and go in any direction that you want, you should always end up at 0, right? So this is, I did this one here. So now if you start here and you go up this way, you gain 10. Okay, then you go this way, you gain 1.11. Why? Because you're going against the current flow. Remember, positive charge always flows from a higher potential to a lower potential. You see? So when you're going this way, you gain 10, and then from negative to positive, you gain another 1.11. Then you go this way, then you lose 7.4074, and then you lose 3.7037. You see, you're going like this with the current. Then that should equal 0. So if you did it right, all the voltage gains and losses should be 0 in any loop, you know. So 10, right, plus 1.111111 minus 7.4074 minus 3.7037. That's it. Yeah, pretty much 0. Cool. So that checks out. You can do any loop that you want. You could even do the big loop, and that should also be 0.